Hi, Breeze. Can you hear me?
I can, yes.
Okay. Let's see. Yeah, I guess I'll share it. Maybe I'll leave you up there. Oh, I know. Wait. Recording. This is all set. I can't hear you though. Let's see. Can you say something, Breeze?
Yep. Can you hear me now?
Yeah, I can barely. I can barely hear you now. I think it's on our end. Let me figure out my end here.
Okay.
It might be there's a lot of background noise.
I can hear the background, yep.
Well, I'm gonna set up a PC computer and then it'll have a video of the classroom so you can see it. Like it'll
Perfect.
also be on Zoom, so it'll just be another window.
Okay.
And I gotta figure out the microphone's here. So I'm gonna put my microphone. Yeah, I don't even. It's just slow. I'm just going slow to make sure I don't miss mistakes. Hopefully next week I'll like check my like that. I'm just gonna go for I haven't had any saying. So far, it's bad. Yeah, I was talking about. Make sure you go to the book at hospital. Yeah, that's the one thing he's trying to treat you a different type of. I didn't realize that. I didn't realize it was different name. Oh, yeah. There's like two dogs. One of yeah, when we get started, so we have Mihaela, Madaras, your son, and Briggs from his husband, son from Detroit. So Briggs, Briggs technical manager, Mihaela's R&D manager, but kind of finance. So it's not just maybe 5 minutes. It's done right? It's on Spring Grove. Yeah, right. I would call it finance. Anyway, so Yeah, so the idea, so I guess Briggs is in Detroit because she was with BASF Power, with some, like there's consolidation of different companies. So they bought BASF Power and they put each other and then, you know, been here.
Mihaela.
So anyway, so they talk about, I mean, theme is additives, but it's so maybe you can talk a little bit about. Anyway, so the field of additives doesn't exactly exist. You're talking about this before. So there isn't really an additive. How do people work? Additives, people working like fillers or pigments, color concentrates, plastics, flame retardants, and it's all have their own technical meanings, so they don't actually get together having additives. So there is no additives. So basically, I think pigments is one of the main problems. So, so even within the pigments, it's like things that go on the surface, like the kind of things, and things that mix in the plastic, probably some other categories. So that I don't know about. Basically, they're different problems, right? So anyway, maybe we can just I thought we just maybe you could say what your background is, I guess.
So, Grace, do you want me to start?
Yep. Do you want me to pull up the screen?
Yeah, you can.
Yep.
Slide, and I'll introduce myself, and then I'll give you a chance to introduce yourself, and then we can get going with the rest of the slides. So until Briggs is putting the first slide on the screen, so I'm Mihaela Madaras. I am the manager of a group that develops preparations from pigments, and we take the pigments and we make them into dispersions or other types of preparations, and they can be used in inks or they can be used in other types of applications. We have coatings, we have, for instance, we have the coatings that go onto the seeds for agricultural applications. They get color coded so that farmers know what seed is what. So even in that type of application, we do have our dispersions that we take and we formulate them and they put on the seeds.
But the pigments and dyes are different things.
Yes, so I'll get into that as well. Just to say that Sun Chemical is part of a Japanese corporation called DIC, or Dining on Ink Company. So DIC is the largest ink company in the world. That's why we know a lot about inks. Inks are the ones that print on various substrates. It can be different technologies for printing. So we know a lot about lithographic inks, inkjet ink, offset inks, and so on. Waterborne, and solvent-borne, and UV curable. So this is our area. To address the pigments to dyes difference, I like to say pigments are not soluble in ink. If you're trying to dissolve them, it's very, very difficult, even traces of soluble pigments. When we analyze them, we have to use extremely strong chemicals to actually dissolve enough for the analysis, right? So pigments are very insoluble. Dyes, on the other hand, they are soluble in various solvents. Some are water soluble, some are solvent soluble. So when you think about dyes, think about something that will solubilize. Now we can also have dyes that are insoluble in water, and we can actually treat them as pigments, but only for water. But they're still called dyes. So that's a major difference between them. What else? So in terms of my background, I was, wondering that I have a bachelor's degree in chemical engineering. And if you hear an accent, it's because I'm originally from Romania, and that's where I got my chemical engineering degree. I came to the US 32 years ago for a PhD in chemistry at UNC Chapel Hill. And ever, since I graduated, I worked in all different areas using colorants. Initially, I made a chromophore for DNA at Ohio State, and then I chromophore being a molecule that was colored and fluorescent. So with that experience, Kodak liked my background, and I went to dyes for inkjet and pigments for inkjet, and I made my way into science. So it seems like colorants have been the major theme of my career. They're different type of chemical than anything else you will find in materials. They can be a blessing or they can be a curse. It's like I said, it's difficult to get rid of them when we're trying to recycle stuff because they tend to color the materials. And then when you color different, especially plastics, with different colors, how do you actually remove that color? That is a major difficulty with pigments and plastics. So I hope we'll address a couple of those things today. If you have any questions, I also want to show you a couple of things about how we remove, how we design pigment preparations from the printed plastics, but there's definitely a lot more out there. Reed, do you want to say a couple of things about you?
Yeah, sure. Can you hear me okay now, or are we still at light?
No, we're really loud. So.
Okay. Yeah, so my name is Briggs. I am a technical manager at Sun Chemical. I specifically work with plastics and our Pigments for Plastics group. So a little bit of my background, I achieved my chemistry degree at Montana State and then a PhD at Purdue, working with inorganic in the inorganic group there at Purdue. And then I started at BSF almost 15 years ago. 3 years ago, we were acquired, the BSF group for pigments was acquired with Sun. So I've been with Sun for about 3 years. So in total, I've been working with pigments for about 11 years, mostly working with more of a technical service, which is a little bit different than Mihaela, is more of an R&D focused. So I do much more with certainly projects that are closer to our end customers, working with problems that they have. Certainly sustainability has been a huge topic for the last 5 years. I've done numerous presentations on sustainability and how we can improve sustainability of plastics, particularly when plastics have gotten a really bad knock in the normal, media and stuff about, plastic waste and whatnot. So we've done a lot with sustainability, both within, like, say, our pigments group and our plastics group, but also our company in general recognize this as where we're going to be going forward and needing to have better sustainability practices going forward.
Something about on your website about bio content of pigments. Is that something that you know about, or that? I was kind of surprised at that. Like, I know the plastics are trying to get like bioethylene, maybe polyethylene, biostyrene, polystyrene, by doing bacterial fermentation and make those molecules more or less. But is that also happening in pigments, something like that, or what exactly is bio-derived pigments? I didn't really get that.
Do you want to take that?
So certainly the push to have more bio-derived pigments and things that are not from a petrochemical source is something, a big topic. I would say there are a few of our pigments that are bio-derived from those type of like a fermentation biological kind of sources. But by and large, most of our pigments are not from that source. I mean, we've, pigments that we've been making for the last, 50 or 60 years, we've continued kind of making them the same way from the same sources. But there is certainly a push for that. There's a push for more biopolymers like PLA and having pigments that can participate in that, particularly when you're talking about compostability. So there's kind of other avenues that we start talking about when we're talking about bio-derived things. So there's certainly some pigments that can be made by those biological sources. But I say by and large, there's it'd be hard to make a lot of our pigments that way. So there might be some other avenues that we would have to look at in order to kind of look at our raw materials and maybe like your supply chain and how picking a better source for your supply chain, those kind of efforts in order to kind of improve like your sustainability of the actual pigmentation, the source of it. Yep.
Carla was talking about the diaper, for so it's not non-toxic inks. So
yeah, so coming back to what we said, the black is probably the easiest to source from biodegradable sources because we can get it from biochar, so if you burn it under certain conditions, you can get a dark carbon black material that could be used, could be grinded, milled, and we can use it, and it has its drawback, but really we come from a bio-renewable source. Another way to make that carbon black is, and there's already some sources out there, to use vegetable oil and burn it in using a gas process. So the way that become carbon black company, when carbon black is going to be oil, petroleum product, they can use actually vegetable oil. And then these are two examples of pigments that come from innovation. We also have other dyes, I would say, that are natural dyes. Not pigments, but they are dyes, and the plant provides that soil with phytocynin of blue, which is extracted from a spirulina variety, and we do have plants in California and plants in China that extract that really nice color, blue color. And
is that the spirulina is like something people eat, right? The green.
yes, you can eat, but it's a special variety of spirulina that is blue color and extracted and can be mostly used in food. Not necessarily used in industrial applications. And it's not very stable. All the natural colors actually have they're not as rise in temperature as the big stuff. So we're done with the isolated by them and do that. There's also other types of pigments that could be isolated from plants, but in general, as we said, those are not yet at the point where they could be used to replace industrial scale pigments that we currently So in general, for the biorenewable,
so they're all kind of they're all kind of biodegradable. The carbon black is or isn't, I don't know.
It's not actually biodegradable, but biochar, which is what we obtain from burning wood, it's used in agricultural settings for enhancing the soil. So, for instance, waste and things biochar also use everything for regular biochar or not, but its presence in the soil is actually good. Because it has the ability to drain soil and it has the ability to retain nutrients for the soil.
Doesn't have an expert in biochar in the chemical engineering, mainly I guess she's environmental, but yeah. So it's some activity in biochar area.
Yeah.
I don't think they ever thought about it as a big thing.
Yeah, so
Mostly that
the main
agricultural.
application is for soil.
Yeah.
But in general, yeah, pigments are not, biodegradable. And also there's materials that we use that are biodegradable. Biodegradability and compostability are a little bit different, right? And compost, you control the conditions for the degradation, and you collect the carbon dioxide, preferably in plants, where you have it, so biodegradability is when you dump the waste, from the area where all the waste goes and slowly degrades, but unfortunately it's other, materials that can reach into the ground. But now back to the biodegradability, we do have efforts that we have tried it, and some trying to replace polymers, resin, surfactants with materials that are similar in structure, but with so that we can use for
I noticed you guys are doing adhesives too, like circularity of adhesives. Any time or whatever, which we might not know anything about that. Like the labels, those labeling and the adhesives, I guess, are a problem with the circularity.
Yeah, I'm not very familiar with that topic. Really, do you know, is the adhesive?
Yeah, I'm not as familiar with that topic as well, but we do know when you're going through that, like the process of trying to recycle things, sleeves, the caps, small parts on things can certainly make recyclability more difficult, and particularly when we're talking about all the plastics that go through like a MRF at a recycling center. It's actually a really small percentage of that actually gets used. And so finding those pinch points like those adhesives, and the sleeves, small parts that, fall through filters, the pigments that can go into them. So using carbon black makes it undetectable. So kind of highlighting those within that recycling system, knowing that it's at this point really not that efficient, and trying to eliminate those or change it or adjust it, so that more of these plastics can be recycled. But the topic of the actual adhesive, I'm not so familiar with. Yeah.
But in Europe, we're talking about banning carbon black for the industry. I saw it somewhere. So you're kind of worried about that, yes.
So we're not as worried about that, mostly because we are, as Sun Chemical, not a primary source of carbon black. That's one of the few pigments that we don't have in our portfolio, but we do have other pigment types that can play in there. And I actually have a slide on it. Yeah, so that's what, okay, so when we're talking about recycling, and why we want to get rid of carbon black, Canada's already implemented. Europe has implemented a lot of reasons, or a lot of places have implemented single-use black plastic cannot be black. And the reason is most of that has been colored with carbon black. Carbon black is an IR absorbing. And so in these detecting systems within the recycling system, they cannot be detected. So you want to get rid of those and replace it with something else, something that can be IR reflective or transparent. It has to be, suitable in, polyolefin and PET, which is most of the polymers that are recycled right now, and it has to have food contact because we're mostly talking about single-use packaging, which is usually food contact needed. So we do have a pigment here that would play, and it's an inorganic. It's a pigment brown 29. It's reflective, and so does not have this part or this issue with it being detectable. It could be picked up by those detectors, and it can be appropriately sorted within that system. So the getting rid of that carbon black would certainly make recycling more efficient. Particularly when we're talking about getting more polymers that we can use or getting material out of that sorting system that is usable. So we can sort by different polymers. That's good. We can sort by, sometimes we can sort by different colors. So all your red goes in one, blue goes in one, yellows go in one. That makes it easier to reuse again. But by and large, most of that goes into clear plastic and then all other colors. And all other colors turned into a pretty ugly goop of gray to black to maybe beige, and it can vary depending on what you have your sourcing being. And that that PCR is what a lot of people are trying to incorporate into their formulations going forward. Is part of their sustainability to use recycled material, this PCR. When it's a really ugly gray to start with, it's really hard to formulate something pretty out of that. So that's one of the biggest reasons why they want to push, they're pulling carbon black out. US hasn't completely gotten there, and they're usually a little bit behind some of these other, particularly Europe. But certainly some places in Europe have already done it, and Canada has already done it as well.
It's good. That's good for sun, right? Because you're replacing carbon black for something more expensive.
Exactly. Yeah. So yeah, we're a pigment that we're primary in. We make it ourselves. So this is pigment. We also have some carbon black, but not a lot. And so it's good for us. But it's also very good for like your sustainability efforts going forward as well.
We have one person that worked at Sun. You have a question?
They have a question. I worked there.
Yeah.
I mean, I did some of the sustainability efforts. I worked on a lot of the food tolerance side of things. I worked in a lab for my first rotation there where I was trying to find a way to stabilize the natural colorants for like a soda application. And I wasn't able to in my time there, but I know that they've continued to work. The spirulina was really cool. I know you guys have a plant that was really interesting to learn about, but I don't know.
Yeah,
You mentioned de-inking. What do you have on de-inking?
So, we are trying to design inks that when printed on flexible plastic, so all the food packaging that you see in the store, all the flexible packaging, all the labels, things that go on the polyurethane bottle, they are all printed, right? And we take them, the plastic that are printed and try to recycle them, you get a very ugly color plastic. So, and the customers are trying to remove that input. And the nice thing about printing is that you have a separate layer that's on top of the plastic that ideally would be easy to remove. Well, it's not always the case that it's easy to remove. In principle, and Bree, can you go to the slide that shows the process that we want by, I try to show what the steps of in the plastic.
Yeah. Yep. Let me just see if I can share it real fast. How's that?
Maybe there's a one with just the process on go, yeah, number 10, slide number 10.
Yep.
Yeah, so this is the process for trying to get that nice light color pellets in the end. All the packaging material is grinded, and then the de-inking is a wash with a very strong caustic solution, hot solution. So that will remove the ink. Now, depending on what type of ink was printed with at the beginning, we can have water-based solvent inks, UV curable inks. The UV curable inks are the easiest to remove because what happens in the UV curable, you have the solvent is a monomer, everything else, the colorant is in there, and then when you heat it with an LED light, the monomer will polymerize, right? So you form a very nice layer of a cross-linked polymer. And usually when you hit that with a toxic solution, it's not that you all you do is you just break it into some plates that get to the top, and then you remove those plates. So ideally, when you do the de-inking, you don't want to redisperse those pigment particles into that caustic solution, because what happens, and if you can go please to the next one, I think that's going to for the last, yeah, the last one. Ideally, you want to end up with plates that are easy and not the almost like dissolved color in the plastic, because that's what it does to the plastic plates. You really want to get to light color, preferably no color plastic that you can recycle into the process, manufacturing something without having a raw color, right? So there is a design that goes into it. Originally, the inks were not designed to be original. The target was the color strength, how rub resistant the ink was, because you have packages and they get to rub against each other, or there's water, wet stuff, you really don't want anything to come off. So initially, that was the target of design inks, is durable, good, nice looking colors, vibrant. Just more recently, we started getting into the recycling aspect and trying to see how there's a being and realize that the waterborne usually go to that conventional the problem with the water is that you design them with resins that were soluble in water. When they dry, they dry on the surface, but when you put caustic over them, they will be dispersed. So the waterborne inks, there's quite a bit of design that should go into that ink layer to make sure that it leaves just like when you have the washable one. And it's done with primer layer on the substrate and overcoat, and there's a lot more that goes into it to make the inks usable. And probably higher cost that go ahead with that. But that's, in principle, that's what inking is, and this is the focus of some of the ink authors trying to come up with solutions. I'm not even sure how long the substrates here in the event are even there's still a lot of it. So the color in the plastic is a major roadblock to cut. So consider that there's about 7% in the world recycling rate of every. That's a big part of that is plastic, so only 7%. But what we can actually get out of that 7% is a lot lower because some of these plastics are really difficult to take back into the manufacturing of the plastic objects or films. And do the way we want them to. So definitely there's a lot more work to be done. But this is one our part is.
What's that? Is that? Sure.
So it's not my picture, but I would assume one of the pricing of plastic, not to.
But it doesn't really matter what plastic. What do you think?
So- Might matter depending on what the individual is bringing to the plastic that. But the particles are so small that are just sometimes getting embedded in the surface of the plastic. Really want to destroy that ink layer and bring it to that field where the particles are very well dispersed in that. It's not the world of invention for the fact because it's really hard to watch the plastic.
You're putting water solution to remove out the dye from the solution itself. The caustic solution is separating the dye from the solution.
The caustic solution is separating the ink layer from the plastic substrate.
So, but is this something you're looking into personal care too? Because in personal care products, to change the pH, they add caustic. Like the pH is quite, they add NaOH, and that can, if it reacts with plastic bottles, wouldn't that also be, if the bottles are colored?
So the colored bottles are different story. Maybe these can talk about that, but so we're just talking about something that not mix the colors, right? It's just the ink layer on top. That's what is being about. In terms of the solutions that are used and methods that are used, we would love to be able to change some of those methods because we can suggest to the recyclers methods that are better for water-based inks than maybe pure or solvent-based. First of all, it's difficult for them to differentiate at that point when they have the plastic waste. You want to know which one is water-based, which one is it's just difficult for them, right? Actually, that's probably that it could be done to post them in a way so that they know what type of materials used. Of course, we would like to be able to have a separate method for the waterborne things because we know, as you said, the high pH, yes, this is what's going to do to them. We would like to be able to then neutralize that and have a different method, but these methods are all established by a German institute. It's called Ingene. They're in Germany. They started probably 20 years ago. And they are the ones who are setting the methods, and those are the methods that the recyclers are using. It's a little difficult to customize these methods because they go by the standard method, it's easier for them.
There's also new methods, like we just had someone who feels they were talking about laser printing where there's no huge that also comes to what.
So the toner inks, I think yes, they will be inked better because they have wax in them. They have more hydrophobic materials that will probably hold on to the treatment better. I have not seen myself things like that in TV, so I'm not Also, I was speculating here, based on what I know, but yeah, I think they should probably do better. on- on-
I guess I'm working on this labeling of plastic, to be worried about that, or
So this is what, Bree, I think you speak to that, I think she's probably.
so labeling of plastics for, I guess for recycling. This, on your webpage somewhere, it says like blockchain ledger, just like Bitcoin something. You kind of keep track of where, how the plastic was handled through the whole life.
That sounds like a good project. I don't, I'm not familiar with it.
Or pigment is definitely needed for our products, like, so, we would love to be able to do that, because they reflect, near our, or avoiding, so they, normally reflect in a range where other things don't. And we use them and a special reader that is on top of the signal that, they be a code for a certain field. But I don't think that it's a very widespread thing. I think we are something to try to get into.
Yeah, I mean, I think that if you cover all the plastic with something like you're saying. And then every time someone handles it, it gets in some place, computer stores everywhere it's been.
Exactly.
And what it is, like from the initial name, the plastics company, like formulation company, everything is all in that thing. It's coded all over the place. And you put this on.
We would love to be able to do that. It's just that for the ink printers, it's difficult to implement this, kind of that especially so this will be like pretty expensive. But you only have to print a very small amount, certain area of the print where you like, there, and that's the idea of it. I think that would be the best way to support, helping the supporting process. So just as Bruce explained that with that one last pigment, that could be fine on a label. And I think we have a couple of things. So,
Yes, I always am surprised, like, every time I go to Sun, it seems like there's a lot of interesting things going on, like the color changing, things with mica, with dark, and it's actually interesting way of working.
oh yeah, for sure.
There's a lot of kind of, well, the car paints, I guess, kind of the pigments for the car paints and
Automotive colors,
yeah, and that's kind of the
actually, we make a dispersion that has extremely small particle size. And when you see the Mazda out there, a Mazda color that has a depth to it, so it's not just a flat color. It's not only a glossy coating, but it's equal to that, actually, we make dispersion that with very, very tiny particles that go into the mid coat. So there's a system there to create that color, but yeah, we want on that, but very, very small particles.
yeah, I had a car, it had a really nice paint job. People would always say that was great. Now it's at Sun, and then he said, and said like, oh, we made that ink, like you could look at it and say, like, that's how they.
Yeah.
But it's pretty funny, yeah.
Yeah.
Yeah. But yes, it's pretty broad spectrum of things.
Yeah, and you mentioned the effect pigments, right? So we have my colors, aluminum. So a lot of the cosmetic, glitter, the very black pigments, the gold, the silver, we do make those.
The Sun is kind of the number one in maintenance now, or?
I, I did look recently, but, Point Bar was competitor, which is, acquired by Sudarshan, an Indian company. A lot going on in India. I want to think overall that the, of the time, and the light.
So it sounds like, it's gonna be rough for you guys to like do much more progression with, recycling and stuff until like government, regulations are made at this point, like standardize like what ink goes on what thing, plastics if you want to like evolve the paint off it, like.
So right now we are designing to have better design, but, so I don't think that necessarily we are the ones that, don't know the solution, so we have solutions. I think that you're right with the regulation. It comes down to the incentives to recycle and, the incentives to reduce the amount of stuff that goes into anything, and even, and that will affect us as a company, but customers might start to drink less, which will be less, right? So using less material to solve things that will be fun, and that it's not something that companies want to do. So we want to keep producing things, but it has to make them functional for the future of this kind of thing.
I would say that, yeah, certainly regulation can speed up the rate of change. I don't know if we really want a lot of regulations as well. As long as it's safe, we still want to have that broad scope of being able to have our full palette for making, brand colors. I mean, that recognition of brand colors is super important to like your end customers that you're buying off the shelf, and colors are playing a major part of that. So there's kind of a fight between how far do we push it with regulations and restricting things and still being able to achieve that thing where we buy with our eyes and having colorants that we like to look at. It's not just a black and white world kind of a thing. But I mean, there's certainly that aspect of it that would change things drastically in our industry if it were to push through. The other thing that would need to drastically happen is that we don't have the infrastructure here for actual recycling, not where it needs to be. And so I think that also needs to come into effect when you're talking about MRFs, cycling centers, places that can, handle this kind of material. And all the way down to being able to, throw your stuff out at the corner and your trash company coming to pick it up, or how do you actually get the recyclables from the consumer? That infrastructure is not really set up, and it's not really robust enough for the recycling loop to be like efficient or efficient. So that's the other aspect of the circular economy, is having the infrastructure to be able to do something once you have it, which is also something that needs to be addressed.
Is it also true that like we're not really recyclers up for success, like with how we're designing packages currently? Like, yes, we should have that infrastructure, but it's right now that infrastructure is so hard to deal with that, like, if we're trying to de stuff, we need to separate down to specific brands rather than, all bottles can be de this way, stuff like that.
Yeah, exactly. So when you're throwing stuff out at your, the corner, we're not sure which one is washable and which one's just your conventional and what you can deal with it at the end. And they all are getting commingled into things. So there's not really that in there. So you could say, okay, well, those, we can just wash those, we can de-ink those easily with these kind of methods that we're coming up with, whereas these other things aren't. So you would have to, if that were to be in place, you would have to have everything be washable, which we're just not at the technology to be able to do that right now. But certainly we're pushing towards doing something like that. But there are other aspects of that circular economy where things can go. It's not just recycling. It's it can go back to that chemical recycling, which I would say this one's kind of like touching on it a little bit, is in bringing it back, you stripping it at everything and bringing it back to its components. I mean, that's another way we can have this circular economy. There's other ways at the end of the life that we can look at, like we talked about composting of material and having pigments that can participate in that composting. There's other places that we can go as opposed to just the landfill and recycling that might also be an avenue that can be looked into.
One issue with packaging. The biggest issue is that not only the packaging on plastic and paper, the fact that we don't have a material. For instance, we have a coated paper, like a paper that's glossy, coated with sometimes resin, so some coatings that make them more resistant to water. With a lot. It's something that is almost impossible because it cannot separate. It's not a normal material. Then to get them fall, separating from that layer, there's no recycling possible. I want to put a lot of magazines and boxes and stuff in all the recycling spots, but this becomes stupid. I know that they cannot recycle a lot of it. It's not easy for them. It's not a raw material. The parts of boxes, I think is going to be recycled as long as it isn't the same problem. And the paper, these things is another story. You have to make things that will produce things already. But a lot of other things that we put in recycling, this is going down in the recycling. A lot of the stuff that we put in is get burned. Or it's end up in the it's not as good as I said, it's stuff you can hold it slowly and you see a lot of those toxic chemicals into the soil. One way is to cover the ground with a plastic soil where some and then still talk about waste. There's the energy plan where but they're so big, they don't have enough waste, and they import waste from other continents. So that's the way but that is one way of burning and collecting all the carbon dioxide. So it doesn't end up in the atmosphere. You also can use the energy that you use in the burning process. So I think that's probably the best of the plan. What to do with the waste, then you can because you definitely want to use this. No. I know we've done a lot of stuff and we didn't know about it, and we continue to do that because they make progress and discussing all the time. But unfortunately, there are other ways.
But there's a few people that were taking paper mix, but the, people in the paper.
So, for those who do not know, probably more difficult because the fall is pretty much becomes like a map. That is easy to think and structure, but you know, process and discuss and actually fiber that now from the you probably don't have
Somebody
I didn't work at, I worked at the Virgin paper mill, but, for recycling stuff, usually it was a downgrade with recycling, paper. Like you, cardboard, go to cardboard, but paper usually went to like toilet paper, like, or like lower quality paper. It did not, you could not go straight to straight.
they strip the labels off the cardboard.
I don't know, I would assume that.
I always rip the labels off.
the color that you get from the type of paper is very
So the most, the high grade paper is like 96% white or whatever, and like recycled paper probably, yeah, the best you can get up to like 92 again. It's noticeably darker. Like newspaper is usually recycled paper, but you can tell the difference between that and like your normal printer paper.
I'm not sure what else. I don't have much else, yes. Do you get any other questions? Kind of others and okay.
Could you talk about how you go about assessing like the end of life kind of environment, like after the payments and guys you use?
So we have an LPA software, the life cycle analysis software that we use. We tend to calculate product carbon footprint and environmental impact ratio of the between what happens from, you know, when the material is made and so we make the product. Because it's very difficult to calculate what happens after the product is, you know, from our country. We can do a trade-off to grade, but under a certain assumption. So the way it goes in the chain, right? So each manufacturer will add their own parts to it. So you can go on here, using some of the outside. We have the product or the system on them. We'll take that into our calculation and our energy that is emissions that we create in the process of making that. And then provide that with the information to the next one in the chain. You know, it depends on each other, it's a chain there. And there's different ISOs for calculating, so we all have to, you know, make sure that we do the right ISO. The third party validations for the KFC calculations are still at the beginning, but we work actually getting more standard out in Europe, how we more faster, something that also product carbon footprint numbers for all of our products that we sell. And we do get customers who ask for a lot more interesting labs and a lot more reporting Now, I mean, environmental impact is sometimes overlooked in time studies. They take into account the, land deforestation that can be with or, impact, the environment without necessarily going out in that part of the system that way. So I think we still have someone going to go until then to have a good picture of how we can impact everybody, not only the and then I think definitely we're seeing a trend. A lot of companies do that, and I think it's easier for the less companies to do it. I think to say the software that is carbon footprint and environmental impact cost somewhere around 50,000. So each one of them. So you can imagine a smaller company, they do have difficulty in doing that. But I think that's definitely one of the things to do and more common. Probably a good enough to go that you're managing all of the public to do so.
That's something people don't understand is a chain of the value chain of how you get to something, how that people get up, and how many companies are talking.
Yeah.
Like each component. Yeah, how you transfer the value chain, I didn't realize it was that, but that's really interesting.
Yeah, so we rely on the public numbers, right? We have the process and we got it correct. And then we pass it on to the next one.
Then the states will be made in that.
And I would say, given that those calculations are still really rough, because it depends a lot on the source of your raw materials. And if you get directly from the supplier, and they actually calculated that raw material from the, we call them a primary data. But a lot of times we have to rely on the databases, so the consultants have databases, whereas when you don't have the raw material information from the supplier, they use the database, and depending on the geography where that was made, depending on so many different factors, I mean, you can direct each that primary data, so we call that the secondary data source. So depending on how you get calculated, you don't know which one will be primary or secondary sources. So I think things are going to get better, but we need some time. It's a process. We're in the middle of a process here, so we're getting to having numbers more. It's a process of recalculating. And so we discovered that there was data was non-fluid, the secondary one finally got primary data. You have to go back and calculate it. And so these are sort of, dynamic. So then
So that's going to be used on the carbon banking platform, or is that when they use that?
I'm sure, well, definitely they should use, and definitely should be helpful. Okay, can you talk here about the carbon thing?
Oh, yeah, it's on plastics. But
Yeah, so there are people who are claiming that they sell these carbon credits, and you are a company that is saying that you reduce your carbon footprint, because another company that grows, they have forest or they have other ways of absorbing carbon dioxide, and they claim to be fair. They own that, they sell you carbon credits, so you as a company can say, oh, I bought some carbon credits from someone else, and I reduce my carbon footprint. So definitely this process needs to be outlined, that definitely has to be regulated, because otherwise, you know, people who can tell you, private service, when you have, you know, it's definitely, it's not a very regular market.
Thanks a lot.
Oh, yep. Thank you.
Original, way best.